Good morning to all of you. Myself, Professor N.V. Adpe from S&D College of Engineering and Research Center, Yeola, working as a assistant professor in Electrical Engineering Department. So now in previous video or previous lecture, we already studied that the types of strain gauge, that is coil strain gauge and all bounded strain gauge. Now in that lecture, we will study, we see the semiconductor strain gauge. In semiconductor strain gauge, the semiconductor wafers or filaments of length varying from 2 mm to 10 mm and thickness of 0.05 mm are bonded on suitable insulating substrates, for example, Teflon. The gold leads are usually employed for making electrical contacts. The electrodes are formed by vapor deposition. The assembly is placed in a protective box. This is your diagram of semiconductor strain gauge. This is a gold lead having base, and this is your semiconductor material. Having two electrodes are connected, and from this we can measure the strain. Measure the strain on the semiconductor material. The advantage of semiconductor strain gauge is the gauge factor of semiconductor strain gauge is very high, about plus minus 130. The semiconductor strain gauge exhibits very low hysteresis, that is less than 0.05. As the hysteresis losses is less, the accuracy of the measurement or the accuracy of the output is more. They are useful in measurement of very small strains of the order of 0.01 micron. Means the semiconductor strain gauge, it is having very accuracy, having high accuracy up to the 0.01 micron. 0.01 micron. The semiconductor strain gauge has much higher output, but it is as stable as metallic strain gauge. It is as stable as metallic strain gauge. It has a large fatigue life, that is 10 into 10 raised to 6 operations can be performed. It possesses a high accuracy response of 1012 Hz, having high frequency response. It can be manufactured in very small sizes, their length ranging from 0.7 to 7 mm. The semiconductor strain gauge having very small size, having the length of 0.7 to 7 mm, means it is very small, very small. The type of semiconductor strain gauge is diffused semiconductor strain gauge. In that, this film element molecularly bounded, no adhesive, into a ceramic layer which is deposited directly onto the force detector. Directly onto the force detector. The adhesive bonded metallic foil element, that is your adhesive gauge. This is stress force detector. This is your stress force detector. How this will be detect the stress, and according to that we can measure the stress by using strain gauge. Second one is semiconductor wafer made of resistance element diffused into the substrate and bonded to surface to thin adhesive layer, that is semiconductor wafer element. This is the layer which will be bounded on the surface of the thin adhesive layer, that is your thin epoxy adhesive layer. This will be bounded on this bound the semiconductor wafer element. The third type is thin film element, molecularly bonded, no adhesive into a ceramic layer, which is deposited directly onto the force detector, that is silicon dioxide insulation gauge insulation, and gauge will be bounded on that material. Diffused semiconductor element, that is the gauge, it will be mounted on the uh, force detector. This is your diffused semiconductor strain gauge. So next topic is water bridge strain gauge. Water bridge strain gauge R2 is set in that there is a use a Wheatstone bridge, like a Wheatstone bridge. Instead of one unknown resistor, we may use the strain gauge. This is your R2, R1, R2, R3, and R1, R4 is strain gauge. R2 is set at a value equal to the strain gauge resistance with no force applied. When the force is not applied, then the resistance of strain gauge, the value of this resistance is equal to the R2. The two ratio arms of the bridge, that is R1 and R3, are set equal to each other. That is R value of R1 and R3 are same. Then the no force applied to the strain gauge. The bridge will be symmetrically balanced and the voltmeter will indicate 0 volts, representing 0 force on the strain gauge. Means at the balance condition, the value of R2 and resistance of strain gauge are equal. The value of R1 and R3 are equal. Then it may be, then we can say that the bridge is balanced. Then the voltage shown by this voltmeter is 0. And when with a single element to the bridge changing, resistance in response to measured variable is known as quarter bridge circuit. Means as the any element from this port is changes, the value of resistance is changes, then the bridge changing resistance in response to measured variable, that is the measured value is changes, that is the voltage, it is known as the quarter bridge circuit. Again, second one is wire resistance. The strain gauge resistance is not the only the resistance being measured. The wire resistance, that is R wire 1 and R wire 2, being in series with the R gauge, that is resistance of the gauge, also contribute to the resistance of the lower half of the arc of the bridge and consequently to contribute the voltmeter's indication. Means in that case, the wire resistance is also added with the uh, resistance of the gauge. This is your wire resistance. Three wire configuration. In that, we use the three wire uh, configuration. In that, the the voltmeter wire is connected to the that point, but instead of that, we may connect this uh, to the uh, to the one end of the gauge, and the wire again this wire will be connected to the R2 resistance, and the second terminal of the gauge is connected to that point. This is called as three wire configuration. Then dummy strain gauge. In that dummy strain gauge, uh, in a in a in that method, one unstressed the strain gauge is inserted instead of resistance R2, and one strain gauge that is having stress is given on that strain gauge is inserted, and according to that we can measure the resistance of the strain gauge, and according to that we can find the unknown strain strain stress on the material. So stop here. In next lecture we can we will see the half bridge full bridge circuit of the strain gauge and Wheatstone bridge circuit of the and bending beam load cell for measuring the stress strain on the uh, any element. So stop here. Thank you.